Hello, welcome to section 3.2. First, you're going to do exercise 1 here, and when you're done with exercise 1, come back and check your answers here, and then I'll go through the forms of the quadratic functions here. This right here, this is a main idea of the section, so make sure to pay attention to that part of the video. And I am recording this outside right now, so you might hear a garbage truck or a noisy bird in the background. So anyways, now's the time to pause it, and in a moment I will show you the answers to exercise 1 here. All right, and now that you've tried it, here are the answers to this. For exercise 1 here, first we're going to plug in x equals 1. That one's going to give you 3 times 1 minus 2 times 1 minus 4 for this first bit, which is going to become 3 times negative 1 times negative 3, which will come out to be 9. When you plug in x equals 2, you should get a result of 0. Whoops, I wrote this wrong. You should get 0 because that's 3 times 0 times negative 2. That's what you get when you replace the x with 2. And when you plug in x equals 3, you'll get negative 3. Plug in x equals 4. Plugging in x equals 4 here is going to make it so this part becomes 0, and that makes the whole thing become 0, because you do 3 times 2 times 0 is 0. And I'm going to plot those points on the graph here. We got, let's see, x equals 1, y equals 9 is right here. The point 2, 0 is here. 3, negative 3 is here. 4, 0, and 5, 9 are there. So when you connect them with a smooth curve to get the rest of the points in between, it should, that's a little ugly. It should look about like this, like a parabola. And you can see the points 2, 0 is right here, and the 4, 0 is right here. And you notice that those show up when you make these two factors of the function 0. All right, and for this next one, let's see. When you plug in x equals 1 here, you're going to do 3 times, let's see, 1 minus 1 squared. That's going to be 0 squared, which is 0. So that's just going to become 0 minus 4, or negative 4. So x equals 1 is what makes it so this whole thing is, so this whole term here becomes 0. All right, when you plug in x equals 2, we're going to get 3 times 1 minus 4, which is going to be negative 1. So, and plugging in the rest of these points gives you these values. So we've got 1, negative 4 is down here. 2, negative 1 is right here. 3, 8 is up here. And 4, 23 is off the top here. I'm going to plug in one more value of x here. I'm going to plug in x equals 0. Just so we can see what's going to happen. Plugging in 0 is going to give you 3 times 0 minus 1 squared minus 4, which is negative 1 squared is just 1. So this gives you 3 times 1 minus 4, which is negative 1. So I wanted to do that so you could see that that point there, that 1, negative 4 point, is the turning point. So you can kind of draw the rest of it here. Whoops. More like that. There we go. Okay. I don't know why I'm so bad at drawing parabolas. They always come out looking kind of weird. But anyway, those are the points that we got. And what I want to point out here is that the 1 -4 point, plugging in x equals 1 is what makes it, again, so this part becomes 0, and that gives you this point there at the bottom. Okay, so let's look at this question. How do the 2 and the 4 affect the graph? We have these numbers right here. Well, because you have x minus 2 and x minus 4 as factors, well, if anything has a factor of 0, anything times 0 is 0. So the 2 and the 4 make it so when you plug in x equals 2 or x equals 4, you get the result of 0. So I'm going to pause it for a second so the sirens can go. Okay, so how does that show up on the graph? Those are values of x that make it so you get a result of 0. That makes these be the the x-intercepts. So in other words, these are values of x that make y, also known as f of x, equal to 0. So those are the x-intercepts. Okay, now how does here we have a 1 and a -4. So how do those affect the graph? Well, 1 is, what happens here is when you plug in x equals 1 into this, that makes this whole thing 0. It makes the 3 times x minus 1 part equal to 0. And if x is anything else other than 1, then x minus 1 squared is going to be positive. So, yeah, if x is anything other than 1, then the 3 times x minus 1 squared part is positive, because squaring anything makes that result positive, and multiplying it by 3 keeps it positive. And so the whole result, the g of x, is going to be greater than -4, because you have this positive number plus -4. So in other words, the -4 is the minimum value of y here. Another way to say that -4 is the minimum value of y when x is 1 is you can say that point is the vertex of the graph. Okay, all right, so let's go over these various forms of quadratic functions. Understanding the difference between these is a key idea. Just like with linear functions, knowing the difference between slope-intercept form and point-slope form and standard form, it was a really helpful thing to be able to understand them. This is extra important for Chapter 3 with quadratics, because quadratics are just tricky. So if you thought Chapter 2 was easy, a lot of people think Chapter 2 is a lot easier than Chapter 3. So this might be a little bit less intuitive. But so if you have something written in standard form like this, just ax squared plus bx plus c, then what does this tell you about the graph? Just a quick review from 3.1 is that if you plug in x equals 0 into this, you're going to get a times 0 squared, which is 0, plus b times 0, which is 0, plus c. So this has the point on the graph 0, c, which is the y-intercept. And what we went over in 3.1 also was that if a is positive, the graph opens upwards. If a is negative, then the graph opens downwards. And there was an explanation for why that is in the 3.1 videos. Okay, so let's look at factored form. So when you have it in factored form, the trick here is that anything multiplied by 0 is 0. And that's true here too. So if you were going to plug in x equals r, let's say, like f of r here, whatever that number r is, you do a times r minus r times r minus s, which is going to come out to be, let's see, a times 0 times r minus s, which is equal to 0. And the same thing is also true for s. If you plug in s, you're going to make the x minus s thing 0. So that's also going to be 0. So the factored form actually tells you the x-intercepts. So r0 and s0 are x-intercepts. And the same thing is true with a. This a is actually the same as this, because once you FOIL this out, if you're going to do the x times x, you'll get x squared. And then once you distribute the a in there, you'll end up having a times x squared. So the same thing is true about a for the factored form. And same thing here. If you have it in vertex form, after you do the x minus h times x minus h, if you're going to square that out, if you're going to multiply that, you'd end up with a times x squared. So the a here applies to, the same thing is true here. If it has ax squared in the standard form, then if that's greater than 0, the parabola opens upwards, and if a is less than 0, the parabola opens downwards. All right. So, what is vertex form here? If it's written in vertex form, then just like in my explanation for part B from the last exercise, x equals h is going to give you the smallest possible value of x minus h squared. So, in other words, hk is the vertex of the graph. All right, so let's see what this looks like in an example, which I'll do in the next video.